Salam, peace be upon you. We begin with a short, woven summary of what we have certified so far in episode 14. We only speak inside licensed windows with passports and declared boundaries. We refuse any claim without a coherence pass and identifiability. We lift the cyclic phase field locally when allowed. We use branch cuts only as bookkeeping, and we reject anything cut dependent. We excise alias zones as counterfeit. We define a certified domain called D, where derivatives are legal. Inside D, we extract the first public carrier, A equals D phi tilde, and we enforce triunity, so time, space, and motion readouts recombine back into A. Now we arrive at part 20, and it is one of the most quietly powerful parts in the whole compiler. Because it takes something that humans love to romanticize and it makes it clean. It takes the word singularity. It takes the word undefined. It takes the word breakdown. And it replaces all of that drama with one honest sentence. Undefined is not mysterious. Undefined is typed. That is our mission in this part. Make undefinedness honest. Make the limits of language visible. Make sure that when we cannot speak, we do not pretend we are speaking louder. We simply admit we are outside the legal range of an operator. Because episode 14 is a compiler. A compiler does not do miracles. It does legality checks. It refuses illegal statements. And it writes refusal certificates when you try to sneak nonsense in as if it is truth. So let us ground ourselves again in the severe discipline we are living inside. We are not describing what reality does. We are not telling a story of time unfolding. We are not using probability, entropy, selection, or agency. We are doing only one thing. We are stating the conditions under which a statement can be publicly certified at all. And now we face the place where most frameworks quietly collapse. The place where people keep calculating even when the calculation is no longer legal. The place where they see a blow-up, an infinity, or a contradiction, and they call it deep. Often, it is not deep. Often, it is just a guard failure. Here is the simplest way to feel it. Imagine we have a toolbox, a real one, on a shelf. A hammer is for nails. A screwdriver is for screws. A saw is for wood. A wrench is for bolts of the right size. Now imagine we pick up the screwdriver and try to hammer a nail into a wall. The screwdriver slips. It scratches the wall. It hurts our hand. Do we say, a profound mystery has appeared in the wall? No. We say, we used the wrong tool for this job. That is exactly what an operator is. It is a tool. And every tool has conditions where it makes sense. Those conditions are not optional. They are the meaning of the tool. So part 20 installs a rule that will save the listener from countless fake mysteries across physics, engineering, medicine, economics, and everyday life. Every operator carries a guard. Every guard is checked. When the guard fails, we do not compute. We classify. That is it. That is the heart. Now let us translate this into the holophase language we already earned. Inside our certified domain D, we have the first public object, A equals D phi tilde. Say it slowly in audio form. A equals the differential of phi tilde. Phi tilde is our local unwrapped version of the cyclic phase field phi. A is the minimal carrier of variation that we can certify inside D, after lift legality, after cut discipline, after alias excision. Then we enforce triunity. We look at A through three readout lenses. Time readout. omega. This is the cadence. It is how A expresses change when we read a long time. Space readout, kappa. This is the texture. It is how A expresses pattern when we read across space. Motion readout or kinematics readout, nu. This is drift. It is how the time readout and the space readout relate in a chosen description. And we already sealed the rule. Omega, kappa, and nu are readouts only. They are not primitives. They must always recompose back into A. If we cannot rewrite a claim in A language, we reject it as smuggled ontology. Good. That is our foundation. Now, part 20 asks, what happens at the points where our tools fail? Because there will always be such points. Not because reality is broken, because our tools are conditional. Let us name the biggest trap first. The trap is confusing not defined with infinite. When a fraction has a zero in the bottom, some people say it goes to infinity. But that is not the honest statement. The honest statement is, the division operator is not legal here. Division is a tool. Its guard is simple. The denominator must not be zero. If the denominator is zero, the tool does not produce a huge answer. The tool produces no answer. It is silent. It is outside its domain. And that difference is not a small detail. It is the difference between science and mythology. Because if we allow ourselves to interpret illegal outputs as physical truths, we can invent anything. We can create infinite energies, infinite speeds, infinite densities, and then we can build entire stories on top of that noise. So we do not do that. We put a guard at the front door of every operator, and we enforce it with a gate. Now we need to say what typed means, because we are not only saying undefined, we are saying undefined in a particular way. In everyday life, if something fails, we do not just say failure. We say what kind of failure. A car fails to start because the battery is dead. That is different from failing because the fuel is empty. Different fix, different meaning. Same word failure, but not the same reality. Typed degeneracy is the same idea. When an operator cannot be applied, we do not just shrug. We label the failure class. We say which guard failed. We say what information is lost. We say what is still safe to claim. We say what alternative operator might apply. And we record this in the audit ledger. Now let us bring this to triunity in the simplest possible way. There is a very common operator people love to compute. It is the ratio operator that produces a motion or kinematics readout from time and space readouts. In ordinary language, people call it speed. In our readout language, it is nu. A very common form is nu equals omega divided by the magnitude of kappa. Say it in audio, nu equals omega over the size of kappa. Now the guard is obvious. We can only divide by the size of kappa if the size of kappa is not zero. So the guard is the size of kappa is not zero. If the size of kappa is zero, nu is not infinite. Nu is undefined. The motion readout is not legal there. And that is not a failure of reality. It is simply the tool telling us, you are asking for a motion readout where there is no spatial pattern to relate to. So we type it. If kappa is zero, but omega is not zero, we have a pure time cadence with no space texture. That is one degeneracy type. If omega is zero, but kappa is not zero, we have a pure space texture with no time cadence. That is another type. If both are near zero, we have near silence in both readouts, and many operators become meaningless at once. That is a third type. And we do not pretend these are exotic. They appear everywhere. In waves, in fluids, in optics, in markets, in brain signals, in climate maps, and in the simplest household measurements. Now let us widen it beyond triunity to the general rule. Every operator has a domain. The domain is the set of inputs where the operator has meaning. Every operator also has a guard. The guard is the check we perform to verify we are inside the domain at the point where we want to apply it. When the guard fails, the operator is illegal at that point. And here is the key. An illegal operator application is not a result. It is a mistake. So Part 20 installs operator guards as first-class citizens in the holophase compiler. We do not allow unguarded operators. We do not allow implicit domains. We do not allow we computed it anyway because it looks interesting. No. We either pass the guard and compute, or we fail the guard and classify. Now we need to connect this to our pipeline, spoken as one line, because episode 14 requires it to be somewhere in the story. Here is the toolchain again, in plain spoken language. Licensed window, then passport and coherence and identifiability, then a declared ceiling and max and an uncertainty budget, then a local lift, then branch cuts if needed, then excisions, then a certified domain D, then A equals D phi tilde, then finite jets up to n max, then invariance collapse, then topology and defects, then an invariant basis, then stability and entities, then scale stratification, then the escape test, then handoff. Part 20 sits right in the middle of this chain. It is the part that stops us from building jet towers on illegal ground. It is the part that prevents us from calling operator failure structure. Now let us make this vivid with examples across scales, but still within our firewall. We will not tell stories of events unfolding. We will talk about measurement and description, not about time evolution. Example 1. Household scale. Imagine we have a kitchen scale and a table. We want to measure pressure by putting an object on the scale and dividing its weight by the area of contact. Pressure equals force over area. Now imagine the object touches at a point, like a needle. What is the area? It is effectively 0. If we blindly divide by area, we get an enormous number. We might shout infinite pressure. But that is not an honest physical claim. That is an operator failure. The pressure formula is an operator with a guard. The contact area must be meaningfully defined at the scale we are working with. At a point contact, at our measurement resolution, that guard fails. The concept pressure at a point is not legal in that model. What is legal is something like force distribution over a finite patch, or a different model of contact mechanics. The fix is not to accept infinity. The fix is to change the operator or change the domain. So the degeneracy is typed contact area degeneracy. Operator guard failure. Example 2. City scale. Imagine we have a map and we want to compute slope of a road by taking height difference divided by horizontal distance. Slope equals rise over run. Now imagine we choose 2 points that are the same location. The run is 0. We cannot compute slope at 0 distance by that formula. The guard fails. We need a different operator, a derivative limit, and even that requires smoothness. If the road is a curb with a jump, then the smoothness guard fails too, and we must use a jump operator, not a slope operator. This is exactly the same pattern, not mystery, just tool legality. Example 3. Biology scale. Imagine we measure a heartbeat signal with a sensor that sometimes loses contact. The signal has sudden jumps that are not the heart. They are the sensor. If we apply a derivative operator to compute instantaneous rate of change right across those jumps, we get huge spikes. We might claim extreme physiological events. But again, that is operator misuse. The derivative operator has a guard. The function must be smooth enough at that point. A sensor jump violates that. The correct action is to mark those points as a discontinuity degeneracy, exclude them or model them with a different operator, and never publish infinite heart acceleration. Example 4. Cosmic scale, but still purely structural. Think about a coordinate chart on a sphere, like latitude and longitude. At the poles, longitude becomes ill-behaved. Many different longitudes meet at the same point. If we try to compute east-west direction at the exact pole using longitude lines, we get nonsense. Is that a cosmic mystery? No. That is a coordinate degeneracy. The operator take derivative with respect to longitude has a guard. Longitude must be a good coordinate locally. At the pole, it is not. We must use a different chart or a different operator that is coordinate invariant. Again, operator legality. Now bring it back to our holophase readouts. We have A, and from A we can extract omega, kappa, and nu as readouts in a chosen description. But nu is a ratio. Nu is an operator output. It is not a guaranteed object everywhere. It requires a guard. And omega, if you interpret it as a period, is also an operator output that requires omega not zero, because period would be 2 pi divided by omega, and that has a guard too. So the compiler refuses all of these naive computations in degenerate zones. And we do something that most frameworks do not do. We keep a degeneracy map. We do not hide it. We do not smooth it away. We do not average it until it disappears. We mark it as structure. Because degeneracy is not only failure. Degeneracy is information. It tells us where certain readouts cannot be separated cleanly, or where a chosen description is not a legal lens. That is why we call this typing, not just refusing. Now we must install the gates for this part, but we will do it as story, not as a list. Gate 1 is the guard registry gate. Before we use any operator, we must be able to say out loud what its guard is. If we cannot state the guard, we are not allowed to use the operator. So if we say nu equals omega over the size of kappa, we must also say, in the same breath, this is only legal where the size of kappa is not zero within our uncertainty tolerance. If we say we take a gradient, we must say this is only legal where the field is differentiable in the certified domain D away from excluded sets, cuts, colors, and alias zones. Guard registry means no silent assumptions. Gate 2 is the degeneracy classifier gate. When a guard fails, we do not proceed. We classify. We do not say singularity. We say this is a kappa zero degeneracy, or this is an omega zero degeneracy, or this is a combined omega kappa degeneracy, or this is a differentiability failure degeneracy, or this is a matrix rank degeneracy, depending on which operator we were trying to use. And we record what is lost. For example, at kappa zero, motion readout nu is not legal. But A may still be legal. Omega may still be legal. So we keep what is legal and we do not pretend to have what is not. Gate 3 is the domain gate. Even if a guard seems to pass, we still must be inside the certified domain D, because D is where derivatives live. So even a perfectly smooth-looking region is not legal if it sits inside an alias zone, or across a cut color, or outside the licensed window boundary. The domain gate says, legality is not only local smoothness, it is also jurisdiction. Gate 4 is the invariance gate. This one is subtle, and it connects to our stress test requirement. Degeneracy classification must not be an artifact of our bookkeeping choices. So we must test that our degeneracy labels remain stable under allowed redescriptions. We do not treat time, space, and motion as primitives, but we can still name them as the familiar readout dimensions. And we must admit, some readout conditions depend on the description. For example, omega itself is a time readout component. If we change the time coordinate within the legal class of redescriptions, omega might change. That is fine. That is not a failure. That is exactly why omega is a readout, not a primitive. So our invariance rule is this. We do not demand that omega equals 0 is invariant under every redescription. That would be projection worship. We demand that whatever degeneracy claim we make is rewritable in A language, or in a coordinate-free statement about operator legality. So the stress test looks like this. We take a legal transformation. We shift phi by a constant which should not change anything public. We shift our lift by an allowed offset. We refine the window slightly within passport legality. We change charts within the same certified domain. We relocate cuts where cuts exist. And we check. Does the set of points where an operator is illegal move only in ways that are expected from bookkeeping, or does it change in a way that would imply hidden semantics? In audio form, the stress test is simple. If we restate the same situation in a different allowed way, the places where a tool cannot be used should remain the same reality, even if their coordinates look different. If our degeneracy map changes in an unjustified way, we have found smuggled meaning. Now let us state the prediction of this part, without dynamics. The prediction is not about what happens tomorrow. It is about what cannot be certified if our rule is true. Here is the prediction. Many famous singularities will stop being certified objects once we enforce guarded operators and typed domains. They will stop appearing as infinite values. They will reappear as refusal zones or typed degeneracy zones. The dramatic spikes will collapse into honest labels. Illegal operator here. And the failure signature, if someone refuses this discipline, is also clear. If you see a paper full of infinities right at the exact points where a guard should fail, and those infinities disappear when you add proper guards, you are looking at counterfeit structure created by illegal computation. Now we must also state a falsifier. Here is the falsifier, spoken in simple terms. If we can write two guards that mean the same thing, and yet the meaning of the computed object changes depending on which guard wording we used, then our guard system is incomplete. That would mean hidden semantics are slipping through. For example, if we say kappa is not 0, and we say kappa is bigger than a tiny threshold, and those are meant as the same practical guard given measurement uncertainty, but the resulting certified claims differ in an essential way, then our operator is not properly typed. We need a refined operator that includes uncertainty-aware thresholds as part of its definition, not as a casual afterthought. That is why episode 14 always demands an uncertainty lineage. Guards are not just logical, they are statistical and operational inside finite windows. Now let us bring this home with a single, unforgettable image that is also true. Think of a cliff on a coastline. If we are walking on a smooth beach, a slope tool makes sense. We can say the sand rises gradually. But if we reach a sharp cliff edge, the idea of slope at the edge using the same tool becomes nonsense. The cliff is a jump. It is not a steep slope in the same category. It is a different type. A careful surveyor does not say the slope is infinite. They say the slope tool does not apply at the cliff edge. We must use a boundary operator. That is the whole part 20 in one picture. Now, because this is holophase, we must also protect the listener from a deeper confusion. Some people will hear operator fails, and they will think we are denying reality at those points. We are not. We are denying the legitimacy of certain statements at those points. Reality does not disappear when your tool becomes illegal. Only your sentence becomes illegal. This is important, because it means we do not respond to degeneracy with panic, and we do not respond with mythology. We respond with a compiler action. We either switch to a legal operator, or we mark a refusal region, or we retype the domain, or we admit the window cannot support this question. Now we end this part the way episode 14 demands, with audit artifacts and a revocation clause, spoken clearly. Here is what we write to the ledger as the audit artifact in part 20. We write a guard registry, a list of every operator we used in this part of the pipeline, with its guard stated in plain language and informal language. We write a degeneracy map, a map over the certified domain D, showing where each guard failed and what type label was assigned. We write an operator failure classification ledger. For each failure, we record which operator, which guard, which uncertainty threshold, what alternative operator is permitted, and whether the region is excluded or merely retyped. We write an invariance stress test log. We record what changed and what did not under allowed with descriptions. Phi plus a constant, lift shifts, chart changes, window refinements, cut relocations where relevant. Degeneracy typing must remain consistent in A language. And we write either outputs or refusal certificates. If a requested quantity depended on an unguarded operator, we do not deliver it. We deliver a refusal certificate that tells the truth. Now the revocation clause. Here is the revocation clause in simple audio language. If any output is produced using an operator whose guard was not registered and checked, that output is revoked. If any derivative or ratio is computed outside the certified domain D, that output is revoked. If any degeneracy is detected and then ignored, and the operator is applied anyway, the result is revoked as counterfeit. If degeneracy typing changes under equivalent guard restatement or allowed redescription without an A language explanation, the whole claim is revoked and sent to the negative archive. And we end with the carry line, because this part has a carry line that can protect a whole lifetime of thinking. Undefined is not mysterious, it is typed. That means we do not worship infinities. We do not worship blowups. We do not build stories out of illegal sentences. We check guards, we classify failures, we keep what is legal, we refuse what is not, and we stay honest. Part 20 is complete. If you want to go deeper into the formal work behind these ideas, you can find it on Zenodo by searching for Holoface. Always, peace be upon you.